Jesus. There is power in the name of Jesus. Yes, there is power, oh, in the name of Jesus. To break every chain. God, you're a chain breaker, yes you are. To break every chain. Jesus. There is power in the name of Jesus. Yes, there is power, oh, in the name of Jesus. To break every chain. God, you're a chain breaker, yes you are. To break every chain.
And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.
Okay, looks like we are live tonight. This one is going to be a lot of fun as usual. Good to see a good audience already, even at this time. Mitchell, thanks so much for the super sticker. You guys are awesome. Like I said, putting my kids through college. Doki Doki Bible Club, good to see ya. Thank you so much. And Stupid Horror Energy, good to have you back. How do you feel to treat me like you do? Yes, we're going to have you on here live singing this song for us, SWE. This song gets me pumped. So I hope everybody enjoyed the little intro there. SFT in the house. SWE in the house. We've got George, brother George. Guys, you won't believe me, he says, but I just finished a 3-hour lunch session. Those are my favorite. George, I saw those pictures. That was impressive, brother. You're making me hungry. Dessel Drace, good to see ya. Praise I am that I am. The whole crew, super redeemed energy. Awesome. George, did you save me any? Okay, let's get down to business. Announcements first. We're going to have a lot of fun on Pump for tomorrow, as you can see here in the banner. We've got Dr. Dino is back with us versus Derek Barnes. Be here for 8:30 EST. We are debating is evolution science. I am pumped for it. I got to be honest with you. I love when Dr. Hovind is here. He's always entertaining. I think even his critics would agree with that. Always makes for a good debate. And I've debated Derek Barnes in the past on MDD within the last month, actually. And he's, yeah, there's me and him. And that was a great debate. Nice guy, good guy. We had a lot of fun. He's in, I believe, medical management. He's also working to be a teacher. So it's going to be a good debate. It's going to be definitely one to remember. There it is. Boom. Is evolution science, 8:30 EST. So, yes, make sure you are here. George, brother George, how's your sore throat? You know what? It's feeling better. Got a good sleep. And I thought it'd be worse after 2 hours of nonstop talk yesterday. But I did what you said, had some lemon water, some detox water. So feeling a lot better, George. Thanks so much, brother. So yeah, be here tomorrow. More good news. We've got Dr. Rob Carter. He's going to be with us. I just confirmed it. So he's going to be here with us on Monday, 8 p.m. EST. It's going to be a heck of an interview. We are going to be discussing some of my favorite topics, of course, heavily focused on genetics. We're going to get into Adam and Eve, arguments that the critics are using against genetic entropy. So we're going to tackle those things, get into the out of Africa, have Dr. Carter address some of the most common arguments that we hear all the time. Carter's awesome. I've read most of his technical papers. I've seen his lectures. So between him and Jensen, they would be my top 2 picks to interview. And boom, he's going to be here. So definitely be there for that one. And as I advertised yesterday, check out our gear. There's me preparing for these amazing streams, debunking the debunkers in the new Devolution shirt. We've got our Pond Scum to People mugs, all of our books, lots of fun. So yeah, why don't we get right into it? Good to see everybody here. I hope everybody is well. Like I said, be here tomorrow. And let's see, good to see you, brother Nicholas. Yeah, we got like 2 people in the chat with almost the same names, Super Horror Energy and Super Redeemed Energy. So somebody's copying somebody. Okay, so today's video was just going to be mostly on linkage disequilibrium. We're going to touch on that with Dr. Carter on Monday too. So it's going to be a shorter video. And then good old Dr. Dan, the pseudoscience man, did a response video tonight. I went through it, and I was shocked to say that I was hoping for more. You know, he totally dodged the hat map data. He didn't even address the allele frequencies paper. And what's funny is I'm going to show you here today that his major problem, and I've got his quote here that he admits consisted of the great bulk of his argument. So we'll just dismantle that here. But he, you know, he wouldn't address the numbers and the simulations that come out on the side of young Earth creation using Mendel's accountant. And I challenged him on some abiogenesis, what I call the abiogenesis challenge, because I find these critics, you know, they're constantly scoffing, even though many critics like Dr. Swamidas would say that, yes, of course, if God did create, he would have created Adam and Eve or the created kinds with built-in genetic diversity. This just makes sense, you know, from that starting position. So even he's pointing out the fact that people that say that, you know, the variation in the world today can't be explained by two people. Obviously, those two people or God's initial creation would have been front-loaded with genetic diversity, and that's our starting point. Okay, that's our origin of life starting point. But these ones that want to scoff, the ones that are kind of out of touch with reality, their origin of life scenario, the abiogenesis, chemical evolution, non-living chemicals evolving somehow, some way, shape, or form into the first life, then answer my questions, my challenge. And Dr. Ryan Hayes, we had a phenomenal interview demolishing abiogenesis, and we're just waiting for someone to take up that challenge. We're going to have Dr. Hayes back on and address the arguments put forth, but it doesn't look like anyone's taken that challenge. So if they got a problem with created heterozygosity, they better take that challenge. And I've challenged Dan to go through the allele frequencies paper as well as the hat map data. I went over all of that thoroughly, so we will, yeah, I just want to point out that I was a little disappointed. So let's get right into it then. I got some visuals as well. Before we get into linkage disequilibrium, let's just get into the fact that for anybody who's watched Dan's video today, Dan is still relying on the TMR4A, okay, as a way to refute my position. Now, the way I see it, he's kind of admitting defeat, because when he heard my argument for it as to why that it just pretends to assume created heterozygosity, he got into defining alleles and how defining alleles is kind of going to make or break it. So I'm going to screen share later a little back and forth we had on his channel on that issue, which I think is key. Now, I'm gonna reiterate it, the TMR4A, because the paper, let's see if I still have it show. The allele frequencies paper title is, please go read through it. Dan, he had no issue with it apparently. Dr. Swamidas had no issue with it. It's titled Adam and Eve Design Diversity and Allele Frequencies. Highly technical, lots of numbers, simulations. So if you guys are into that, please read it. And let me see here. Okay, so I got some notes on what the things he said. So yeah, I want to point out the fact that the TMRA, the TMR4A argument only pretends to assume created heterozygosity. Okay. Now, I pointed out as well that they never want to address the uniparentally inherited DNA, and because that's where we would agree that the DNA differences are a reflection of time, reflection of mutations. That's where the predictions come into play on the history of civilization, genetic markers, so on and so forth. But they want to focus on this, you know, recombining DNA, nuclear DNA, that even he admits is a little bit messy. So, like I said, and I'm going to reiterate the abiogenesis challenge by the end of this, because maybe it's just been hidden in all of our responses over the last couple of weeks. So I don't want them to have an excuse that they haven't heard it. I know they have heard it, but I'm going to reiterate it today as well. So he completely dodged the abiogenesis problem, as they always do. The challenge is out there for Erica as well. Dan wants to nitpick at population genetics related arguments, okay? And also nitpick at this hypervariable alleles issue, when in fact I find it funny that he's the one who believes all life on this planet evolved ultimately from a single-celled like ancestor billions of years ago. And that single-celled like ancestor evolved into everything we see today through what? Slow incremental processes, and the mechanisms being genetic mistakes. Okay, they don't want to admit it, but mutations are akin to typographical errors in a text. It's a change in the nucleotide sequences. It's akin to a change of a letter in a book. This is just a fact, and it's much easier to, break the message down than build it up. Of course. Now, also natural selection is going to act upon that variation created through mutations, but natural selection only selects. It's a fine-tuning process. It's all about who reproduces the most. I like to define it as differential reproduction. But it's not a creative mechanism, okay? And even with one or two, or I'll even give Dan 5, because I think in his debate with Kent, he provided roughly 5 examples of supposedly beneficial mutations that got no deleterious effects. We did a response to that, which we've had no response back, which is fine. And we addressed all of those in detail sufficiently, and he hasn't responded to those. But even just giving him those, then, Dan, have the 5 truly rare beneficial mutations. Let's just say they got no deleterious effects. There's a net increase in information. Fine. You're still not going to get, though, the type of change necessary to take a single-celled like ancestor into everything we see today. Oh, and remember that first single-celled like ancestor had to evolve from what? Non-living chemicals. And so if you think you have a better explanation for the origin of life rather than that of front-loaded genetic diversity, you'd better answer the abiogenesis challenge. But what's good is he's now, it seems like he's taking Swami Das's advice. He's taking the lead there, that let's assume created heterozygosity. And that's why they think this TMR4A is an issue. And I like it because they back themselves up into a corner, because the allele frequencies paper that even Swami Das admitted, okay, this seems to resolve. It gives a plausible explanation for the allele frequencies. Doki Doki, I see in there, sticker, super sticker again. Game over. I love it. Thanks so much. You guys are going to love the debate tomorrow. I'm pumped. So make sure you're here. Spread the word. So they kind of back themselves up into a corner, because now they're saying, okay, yeah, the allele frequencies, based on numerical simulations from Carter, Sanford, a couple other authors on that paper, it's given a plausible account for how the allele frequencies and distribution we see today could have come from just 2 ancestors roughly 6,000 years ago in Adam and Eve. Now they're leaning on this TMR4A. Okay, what this does is it traces the origin, and I explained this in our last video, of our autosomal DNA differences back in time. It incorporates recombination and mutation. This is what's important, okay? It then allows the researcher, what they can do now is they can follow lineages. And what the TRM4A point would be is when 4 lineages are now present in the human population. This is the point where 2 lineages could be present in Adam, in a heterozygous state, of course, and then 2 in Eve, also in a heterozygous state. But the entire analysis still treats, okay? And he did not address this because this is a fact. It still treats every difference as the result of mutation. It traces their mutational heritage in a more sophisticated way. This comes down to sophisticated population genetics, okay? In contrast, the created heterozygosity hypothesis, not the straw man version of it, treats millions of DNA variants as what? The result of de novo creation. These DNA variants were front-loaded in Adam and Eve. That would also apply to all the original biblical kinds. Now, I want to point out the fact that front-loaded genetic diversity necessitates nested hierarchical patterns, because those DNA differences are there, okay? And they are a reflection of those patterns. So right off the bat, if a scientist were to show up at the creation event and start doing genomic sequencing, genomic analyses, looking at morphology, anatomy, physiology, they will conclude some type of descent with modification when in fact Adam and Eve and the created kinds were just created de novo. So anyways, back to TMR4A. So in a sense, in the terms used in the TRM4A analysis, the created heterozygosity model puts millions of lineages in Adam and millions in Eve. Now, Dan in his video today, this is what he said, more or less, and Brother Nicholas says, young earth creation is the most honest take on science. I agree, Brother Nicholas. I agree that young earth creation is really the only is the only consistent, non-contradictory position with theology. Because I've noticed with these old earthers, they're kind of a rare breed. Because you'll see like Fuzz Rana, who now because of his position, and they've made predictions way back in the day. You can see Hugh Ross versus Kent, where they predicted Neanderthals were not human. Then we got the DNA data that suggests they were human. We have genes from the Neanderthals we interbred. So now because the old earth position it's contradictory to the science. So now you see them constantly putting forth reasons why maybe Neanderthals and these other hominins, which are clearly human, are not human. But yet how do they explain the interbreeding? The fact that fertile offspring were produced, which would explain the why we share the genetics with them, why we have a small percentage of Neanderthal genes. So yeah, I agree. It's the only consistent view, theology and scientifically speaking. So here's what Dan said in his video today. And he admitted this is his big bulk. And yes, I did address this. It's actually addressed in the paper that I said to read. Dan complains that my videos are too long, which is why I showed some highlights of the paper and I suggested go read it, provided a lecture on the HapMap data, no response. So I guess next time I'll just go through the papers that are, 20 pages or whatever they are and read them one by one and keep these 3-4 hours. Okay, so here we go. He said, if I have a gene from mom and from dad, Stupid Horror Energy, thanks for the super chat. Let me just read it real quick. I'm not prepared for this video, but what does the non-random association of alleles at different loci have to do with young earth creation? Yeah, we're gonna touch on that actually. So this is gonna be allele heavy. So get ready. So here's what Dan said. He said, if I have a gene from mom and a gene from dad, and they're both different, they are heterozygous, different alleles for that gene. Let's say the gene is 1,000 nucleotides. Okay, yeah. And 100 of them are different from each other. How many different alleles do I have in there? Is it 2? Dan says in order to get more than 2 alleles in that gene, we need recombination in there. Well, for one, he's already forgetting another mechanism, gene conversion. So he should have thrown that in there, which would help with the case. He says the rate of recombination is too slow to break all those different variants up to get so many different alleles. Okay. For one, the question I would have would be, doesn't gene conversion break these up faster? And the answer is yes. There's different processes other than recombination, of course. And it's obvious that God would have placed, assuming created heterozygosity, God would have placed these design variants in useful linkage groups. That's the quick answer. Okay, God, and that's what's funny. That's why they want to pretend to assume created heterozygosity and then use an argument that assumes away created heterozygosity, like this argument, as if God just placed these design variants in Adam and Eve, the biblical kinds, but then, oops, forgot to put them in useful linkage groups. They can't break apart. So that's just silly. God obviously would have placed these design variants in useful linkage groups. But we're going to get a little more technical anyways. But that's just the quick answer. So I want to screen share a conversation that we were having, because even Dr. Frello was corrected on this in Jensen-Frello written debate. Okay, screen share. And admitted that he had the incorrect definition of allele. So it looks like Dan is kind of now accepting the TMR4A position that I'm pointing out, but now he's pointing out the fact that even with the allele definition that we should be using, there's going to be an issue because those variants cannot be broken apart correctly. So just 1 second. So I'm screen sharing. Make sure it's good. Just going to get a drink of water. Good to see everybody. Doki doki. Faithful, honest, and true. You're late. Better late than ever, though. Okay. Get a drink here. All righty. Let's go into here. Stacy. So I went heavily into this yesterday. And I'm going to challenge I've been using the HapMap data, fascinating data that suggests biblical creation. I've been using that for months. Use it in Erica's debate. Even had, you can go to the third debate, skip to my final slide where I have a list of questions broken down. It's funny. She'll say that, I don't make it easy. Instead of watching a 2-hour video, just break down the questions I want answered. Well, it's the same question 6 months ago or 4 months ago, whenever that debate was. Time flies by. Linkage groups is one of them. HapMap data is one of them. So I'm suspecting if Dan didn't even want to engage the HapMap data in the lecture, then there's probably no good answer out there for it from the evolutionary perspective. Okay, so there's a lot of comments in here. You can go read it for yourself. Here we go. So I decided to jump in because Catherine Stormgard actually looked like she was being objective and wanted an answer. So therefore, I didn't mind getting into this instead of just a comment war where someone's not really looking for an answer. So here's what I said. Yes, Dan seems to have adopted the improper definition of allele. You're right. I did point this out in my stream last night. But I hope Dan deals with it in his response. He kind of did, I guess, but yeah, we'll get into that. Firstly, when it comes to the hypervariable positions, it is a fact that some regions of the genome seem more prone to mutations than others. Okay, let's see. Well, I'm going to point out the fact too, with what we now know about epigenetics and what goes on in the genomic, in the genomes of living biological organisms, we've got millions and millions of switches just ready and willing to be turned on and off based on environmental stimuli. There seems to be genetic algorithms in our genome that are built in to adapt. And we can see that there are various genes that are only expressed under certain conditions, RNA genes like pseudogenes, for example. So there's a lot going on in the genome that would suggest that these genomic regions, oftentimes the hypervariable regions, the fact that they're more prone to mutations, more prone to adaptation. But yeah, let's get back to this. So now the correct, Nicholas says epigenetics. Yeah, we're going to be talking a lot about epigenetics on Monday with Dr. Carter, Nicholas. So it's going to be a lot of fun. Okay, so I continue. I say, now the correct definition of an allele is one of two or more versions of a particular DNA position. So here's where they cornered themselves. You can watch a discussion I had with Speed of Sound. It was an hour discussion just on alleles and the definition for it, and he just wouldn't answer. He wouldn't give a straight answer because they contradict themselves with their definitions of allele, okay? So I say Dr. Frello accepted this definition with Dr. Jensen after Dr. Jensen corrected him in their written debate. I wonder if Dr. Dan will also admit either correction or admit he has been applying the correct definition erroneously. How many DNA positions in a gene, I asked. How many genes in the genome? Genes obviously consist of more than one DNA position. And this is, the questions I was asking Speed in our debate, and I've done it in many debates with Adam Heap, the zoologist, herpetologist. That was a lot of fun. Because remember, they parrot a lot of the same arguments. So I continue here. As Dr. Jensen explains in his written debate with Dr. Frello, by definition, genes consist of more than one DNA position. So which is it? Is an allele a version of a particular DNA position or a version of a gene that contains hundreds to thousands of DNA positions? Frello can't have it both ways. Stupid Horror Energy is just killing it with the super chats. Don't worry, SW. I put the hammer down onto whoever blocked you for that time being. So you're back. We like freedom of speech here. So anybody can comment, unless there's trolling going on, unless there's spamming. You know, a comment here, comment there. But I'm not going to spend all day in comment sections. Typically, I prefer dialogue and debate. So she says you can also have like a faulty DNA replicase kind of stop over a region of DNA. It could fool you into thinking it's Lamarckian when it's just stuck over that region. I got to say that SWE, I like her super chats. I like her input. She's intelligent. I've had debates where the person I was debating had no answers to what I was bringing up, but then SWE and I got to have a super chat debate. The Team Skeptic debate comes to mind with the chromosome 2 fusion. Okay, so let's see. Okay, so in my Refuting the Critics book, I document this interaction between Jensen and Frello, which also applies to my interaction with Dan. And you can read this. I'm just going to go right into what Jensen says. And this is important. Some of this is technical lately, but it's the nature of the beast, I guess, when you're taking on these. Well, to me, it seems like Dan, he felt like he had to kind of go and almost hide now the arguments in like population genetics and that which is technical to the point where 99.9% of people aren't going to understand the argument. And I reiterated Dan's argument in the comment section to some evolutionist named Zach. And I said, can you explain this to me, what Dan means? And he didn't have an answer because he said I was refuted, but then he didn't even know what refuted. He did not explain the argument. So like I said, you know, all they got to do is put a response out and they're going to think they won. So unfortunately, we got to get a little technical here, but it's fun. It's fun. So he says, and I see Luca in the chat. So good for Luca. He agreed with the definition. He posted the correct definition about DNA position rather than unit. Okay, so let's see. The argument rests on his erroneous adoption of the second definition, that alleles are different versions of genes. Under this definition, he misrepresents my explanation for nuclear DNA differences. In fact, in one of my published papers, what's funny is this paper right here, the Lyle Jensen paper, 2016, was the one that Dan said he sourced and critiqued. But yet, his misrepresentation of the levels of genetic diversity in Adam and Eve, the biblical kinds, creation, when the initial front-loading event took place, was addressed in that paper. So it's a lengthy paper. I doubt he read the whole thing, but maybe he did. Maybe he just missed that part. So, and even Jensen points out that he referred to it 15 times in replacing Darwin. So here we go. Frello's error. If an allele is defined in terms of a gene unit, then generating allelic diversity by mutating just one gene per mutational event produces little diversity. Instead, if an allele is defined as a single genomic position, okay, and what's nice about Luca is he provided in the actual definition. He sourced it, and this is it. This is the correct definition. So if an allele is defined as a single genomic position, independent of its relationship to a gene, then enormous allelic diversity can be generated by mutation. As an aside, allelic diversity need not arise via mutation. Again, if we use the genomic position definition of an allele rather than the gene unit definition, other mechanisms besides mutation can generate allelic diversity. For example, a single gene typically spans thousands of nucleotides. So remember, this is what Dan was saying too in his hypothetical. And SNVs, right, single nucleotide variants, might be distributed throughout that gene. So for example, so Jensen's using the example of about 90. So let's say at 90 of the nucleotides within the gene, we got SNVs. Okay, now if we allow for the genomic position definition of alleles, every single one of these 90 SNVs may have existed in a heterozygous state in each of the individuals of the pairs brought on board the Ark. Now, expanding this single gene example across the entire genome reveals a tremendous potential for allelic diversity on the Ark. In just 2 diploid individuals, 4 genome copies exist. Since only 4 DNA base pairs exist, virtually every possible genomic position allele far more than the 4 to 28 gene unit alleles, could have been present at the time of the flood if the individuals were heterozygous. So I read through this yesterday. I reiterated in the comment section. I don't want to bore everybody, so read through that. We go here. I also did address his ABO blood types, the hypervariable regions. Yeah, so lengthy conversation here. Dan didn't respond. Kind of responded in the, here's the paper again, guys. Please read it. Adam and Eve, Design Diversity and Allele Frequencies. RJ Downard's in the chat. So James Downard. Yeah, so I'll challenge you too, James. The same challenge I've been given Erica, Dan. Take the Abiogenesis challenge, and I challenge you to go through this paper here. Adam and Eve, Design Diversity and Allele Frequencies. Refute it. You won't be able to. And also go through the hat map data, go through the lecture I provided in the last video, everything Dan dodged. Team dodgeball, dodge, duck, dip, dive, and dodge. 5 Ds of dodgeball. So yeah, we'll be looking forward to that video there, RJ. I doubt we'll get it though. Okay, so let's go to Dan's argument now. He had no dispute to the definition. Maybe he's going to be like Frello and actually adopt the accurate definition. Okay, so let's see. Let's demolish that. And he admitted that this is the bulk of his argument. This is the bulk of it, you know. You can't make this stuff up. So let's address this ridiculous argument. Now remember, though, he wants to pretend to assume created heterozygosity, but then continue to misrepresent created heterozygosity. You cannot make this stuff up, like you said. So like I said, I addressed this in my books. I addressed it in that video. It's also addressed in even more technical details than I do by Carter and Sanford, and I believe Jensen. Okay, let's see. So let's assume created heterozygosity like Dan wants to pretend he's doing. Now, all we need in Adam and Eve in terms of heterozygosity to explain the data is a relatively small fraction of their genomes to be functionally heterozygous, okay? Now, this means that if they have functional heterozygosity at a small portion of their nucleotides, recombination and, what he failed to mention, maybe it was just by accident, and gene conversion. But I find it interesting that he didn't mention gene conversion in the above quote. That can certainly help to break up these variants. But that's besides the point. That's just icing on the cake, okay? These processes will lead, okay, to an essentially unrestricted range of valuable diversity. This beneficial diversity is what selection now is going to act upon the most effectively. This is what natural selection will prefer, of course. And so when we see adaptive selection occurring, it is now safe to say that oftentimes it is due to the recombination or segregation or gene conversion, for example, a lot of processes going on of these useful variants that were obviously, if assuming created heterozygosity like they want to pretend to do, designed to recombine and segregate in the first place. So they're proposing God front-loaded Adam and Eve with these designed useful variants, but then oops, he didn't put them in useful linkage groups. You know, how did God forget? You know, this is how silly these arguments are. And my question too, with a lot of these mechanisms in our genome that help with change now, we see rapid evolutionary change. Now, these are horizontal changes, not the vertical changes they require. Organismal adaptation, epigenetic adaptation, these are forward-thinking mechanisms. I've asked this question over and over again. I've got a short 5-minute clip, I think, in my Refuting Gutsy Gibbon playlist, where I asked her directly in a debate how and what type of evolutionary processes, natural selection and mutation, can evolve that which requires forward thinking. Natural selection sees the short term, okay? Doesn't see long term. And how do you explain that? Are you going to propose evolutionary mechanisms have a mind? You know, that's pretty much what they have to propose. And taken directly from the debate, and I love when they pull out their storyboard. So, okay, so let's go back to, his argument here. And once again, if he's got a problem with our initial starting point in regards to origins, take the abiogenesis challenge. And we're hoping somebody does. And I'll go into it in a minute because we want Dr. Ryan Hayes back on here, where Tony, Dr. Hayes, and I are going to demolish any arguments that come forth from that challenge. Okay, so adaptive selection. It is safe to say then that oftentimes it's going to be due to the recombination or segregation or gene conversion of these useful variants, okay? Now, here's the thing. Here's the final blow to the argument, which I've already addressed anyways. Since they want to ignore 99.9% of everything we say in our videos, let us make this short and sweet. These design variants, these front-loaded DNA differences would obviously have been created within what? As I said earlier, within useful or beneficial or helpful linkage groups. Use whatever word you want. I now see why Dan did not want to rebut the allele frequencies paper. That from my understanding, and Dan confirmed, not even Swamidas has an issue enough with to refute. But these useful variants, these design differences, okay, would have originated at high allelic frequencies. Now, the point is, Dan is hoping that people are ignorant of this. I've read the creationist technical literature. I read the other side's literature too. I'm not ignorant of this, of course, which is why Dan's not going to sneak these past me. I will respond, and here's the thing, because all of us that work on this channel are up to date on this stuff. We like the back and forth. We'll respond 1 billion times until they realize that they have no argument to stand up to and with. So here, I want to point out a quote from Sanford. I've got Call Me Emo in the chat. Keyboard Warrior. Emo, would you like to join? And we can discuss created heterozygosity. Okay, so let's see. Dr. Sanford here explains it. Functional linkage groups and high initial allele frequencies greatly enhance selection efficiency, thus enabling rapid local adaptation. Like an ordered deck of cards, the net information in such a scenario would be greatest at the beginning, but diversity would be greatest only after many cycles of shuffling. Except at the beginning, no new functional information would be required. For Dan to actually argue against what I just said, he now has to resort to not assuming created heterozygosity again. It's all a big circle with these guys, which puts him in a circular position. And I'm sure he's going to have no problem doing. Before I get into linkage disequilibrium and the abiogenesis challenge, I wanted to point out the fact that the very paper that he said he read and didn't want to actually address has the information. Let me see. Oh, SFB Mob. Did you have a question, brother? Let me see. He says, are you paying attention to the chat? That's how alleles are like finite state machine connector lists, these group lists. Yeah, good to see you, brother. You do. Oh, here it is. Why is there a debate on this? He says, alleles are pre-programmed lists used for limited diversity arrangements, similar to how finite state machines are used in artificial intelligence heuristics layers. This guy, yeah, SFB Mob, I've seen your stuff, brother. You're great. I got to have you on here to discuss this definitely soon, whenever you're free. That's a great point. There is no debate. And I always say, you know, they try and accuse us of not being able to identify that which is created, that which is mutation a lot of the times. A good function comes down to function. Good rule of thumb, though, if it's common, if it's not disease causing, if it's functional, it's created. The rare ones are obviously mutations, post-flood, post-Babel. Okay, so I wanted to go to Stupid Horror Energy says, how do you explain that Neanderthal DNA is 99.7% identical to present day human DNA? How do you guys explain that exactly? They're clearly human. They're only 99.7% Humans today are all 99.99%, but Neanderthals had a different history, different mutational events. They were highly inbred. They suffered from a very high genetic load. They were 40% less fit. You can find all of this in the secular literature. And it is consensus for the most part that they existed in small people groups, highly inbred. And when you exist in small people groups for a while and you're highly inbred, what occurs is rapid genetic drift, fixation of new deleterious alleles, and then they go extinct. And then humans are changing, adding new genetic diversity for thousands of years after the Neanderthals have gone extinct. So they've been independently changing for, here's the question for the evolutionists, according to them. So humans leave Africa. They've been evolving independently in Africa for however many thousands and thousands of years. They go through this radical genetically reshaping bottleneck, okay, where their levels of heterozygosity are reduced, levels of homozygosity are increased. All these deleterious mutations are coming to the forefront. They're manifested, leading to rapid and accelerated genetic degeneration, while the paleo experts in human evolution would have to say that since humans left, what did they find? Other people groups, human forms like Neanderthalensis, Denisovans, Heidelbergensis, Floresiensis, Naledi, Luzonensis, you name them. I love studying that topic. That means they have to invoke 2 out of Africa's where a subgroup of Erectus left, okay, prior. Just a subgroup left and would have hypothetically independently evolved into these other human forms. Now, when humans leave and they meet up with the Neanderthals, they interbreed and produce fertile offspring. How did they remain interfertile after the radical genetic reshaping that went on in Africa with the humans? And the Neanderthals were also independently evolving. I think they were separated for, I'd have to pull it up, maybe 100,000 years. A long time, though. They should not have been interfertile. So yeah, they're the ones that got the questions to answer on that one. So good question, though. Off topic here. I want to go back to, okay, so this is right from the paper that, I want to point this out too. Fascinating lecture from Dr. Jensen, where he actually goes into incredible detail on this. He has some awesome visuals. I highly recommend it. It was in the last couple months on Adam and Eve, population genetics, goes into mtDNA, Y chromosome. So when it comes to creation, what we see in terms of diversity, in terms of allele frequencies, for example, when you start with a tiny starting population, followed by rapid and exponential growth, lots of variety present at the start, of course, created heterozygosity. Shrinkage is rare, but when there is shrinkage, it's quick. Growth is the rule. Guess what? It fits the data. And you can find this in his lecture. You can find it in, I'm not even screen sharing. Oh yeah, no, you guys can see. Yeah, so I just wanted to point that up. See, here's the thing. They never address the details. I challenge them with papers, lectures. They never touch on it. Let's check the chat here. Yeah, so Neanderthals were clearly human in every way. Okay, so here's the paper. Here's a couple excerpts from, might be difficult to see, but I've got it in front of me. Okay, so it's a little blurry, but I'm going to pull it up in front of me here, where they point out in the actual paper that Dan says that he read, they point out that these design variants, and this was all done in simulation. The numbers are there. I think one day, because the critics are ignoring these papers that I recommend they read, I think I'm just going to go through these one day and go through it page by page, sentence by sentence. They might be 4 or 5 hour videos, but until they, okay, so right here. So it's hard to read on the screen, but it says it right in the paper. It says, in addition, all those designed gametic variants would logically have been created within linkage blocks that were designed, specific, and functional. Our design gametes model appears to not only help reconcile the literal Adam and Eve with observed allele frequencies, but also with observed linkage block patterns. Where's the other one? Right here. Their conclusion. So the numbers are there, and all of these parameters. So they considered these things, and the simulations don't lie. And in the conclusion here, they say, in this paper, we have used logic and numerical simulation to show that there are several design diversity mechanisms that can reconcile a literal Adam and Eve with the allele frequency distribution now seen in the human population. Another thing that came to mind on Neanderthal, it's so funny because groups within chimpanzees that everybody considers the same species, they have more diversity separating them than Neanderthals and humans do. But some paleo experts, people like Dan, they're so adamant to say that it's a sister species, that they're not actually humans, that there's some kind of pre-humans, primitive humans, sister species, whatever. When in fact, it's just so contradictory. It's funny. Let me see here. Stupid Whore Energy says, why does a very small population of orangutans have lots of genetic diversity? What do you think is the cause of that? A lot of times, like for example, cheetahs would be within the same felid family. The felid family overall has high genetic diversity, but that cheetahs experience such a significant genetic bottleneck that they have extremely low genetic diversity now, highly degenerate, their sperms degenerate. Conservationists are worried that they're on their way to extinction. So these orangutans that still have high genetic diversity, apparently, so for the cheetahs, they've gone from 10,000 to 7,000. And the length of the bottleneck is important too. So for example, the hypothetical out of Africa scenario, humans have low genetic diversity, which makes sense. Adam and Eve were created as two, plus the Babel bottleneck, while animals would have migrated all parts of the earth. So overall, exception proves the rule. You can find an exception here and there, but animal families are overall going to have higher genetic diversity. Now, if there's some orangutans within the now, when it comes to apes, kind-wise, it seems like the genetics based on orphan genes, endogenous retroviruses, DNA function, molecular clocks, it seems like the kinds, you'd have the human kind, you'd also have the chimpanzee and bonobos that descend from the same kind, you'd have a gorilla kind, and an orangutan kind. So it all depends on their population history. Have they been in a population bottleneck? I mean, chimpanzees have high diversity too. So if there's just a small separate subgroup of orangutans, I'd be interested to see it. She says they came from a large group, so broke off from a large group that would have had more heterozygosity, broke off. Now, eventually, if it's a smaller group and if it stays smaller for a lengthy period of time, generations after generations, and there's a lot of inbreeding going on, for example, then eventually you're going to get shifts from heterozygosity to homozygosity. A lot of deleterious alleles are going to come to the forefront, for example. So there's a lot of factors at play that will eventually reduce their genetic diversity. Like, for example, the out of Africa population bottleneck 70,000 years ago for humans, it wasn't just immediate reductions in genetic diversity. That's why they need to resort to a lengthy bottleneck. Not just one generation, not two generations, but it's even hard to find an exact number because all they're doing is looking at the genetics and they're saying, okay, how many years, 1,000 years, 10,000 years is it going to take to reduce the levels of genetic diversity that we need it to explain the data today? So it all depends on the length of the bottleneck. Like, for example, a lot of the animal kinds that had a lot of heterozygosity built in, the bottlenecks with the flood, the flood bottleneck mainly for the animal kinds. It was one generation followed by rapid and exponential population growth. So very little of that heterozygosity would have been lost. So I have fun answering questions in the chat, but I don't want to do this all night. So let's go. So the conclusions. Thanks a lot, SW. Now I forget where I was. Let's see. Okay, so In this paper, we have used logic and numerical simulation to show that there are several design diversity mechanisms that can reconcile a literal Adam and Eve with the allele frequency distribution now seen in the human population. Some of the mechanisms, they conclude design diversity within Adam and Eve's 4 sets of chromosomes, followed by accelerated genetic drift associated with multiple population constrictions. As above, combined with more powerful demographic forces such as selective sweeps, lineage extinctions, and differential subpopulation expansions. 3, design diversity within Adam and Eve's originally created gametes. Together, these various genetic mechanisms seem to falsify the claim that there is no way that 2 people could give rise to the human allele distribution that we see today. So I've gone through this paper numerous times. I challenge the critics to do so as well. I challenge Emo to go through it and finally answer. Emo's the worst at answering questions. I mean, the guy just dodges 99.9% and then asks a question that he's not really looking for an answer to, which is why he won't jump in today. What's funny is I've had, 5 or 6 debates with David. I always give him plenty of equal time. We have great debates, but Emo is terrified to jump in here with me, even though I'll be nothing but respectful, give him equal time. So let me get to the next phase of this. Guys, you're just joining us. 30 people at 3:30 in the morning. This is great. So for those that just came, tomorrow, Ken Hovind and Dr. Barnes, Rob Carter. I am pumped. Rob Carter on Monday, 8 o'clock. We are going to be tackling these same issues that we're talking about. I mean, he was co-author on this paper, allele frequencies paper. So this is going to be fun. Stupid whore energy, another super chat. Sorry, I just want to give you money. Hey, we don't mind. We want to do this full time one day, so we appreciate it. You guys are the life and blood of this channel. I've got SFB mob, dude. I know. If I could interview anybody based on who I've learned so much from, it would be Dr. Sanford, Dr. Carter, Dr. Tompkins, or Dr. Jensen. So I managed to get Dr. Carter on. Monday is going to be awesome. So any specific question, we're going to be touching on out of Africa, some of Dan's arguments about like African diversity. We're going to go into the created heterozygosity hypothesis, talk about the retrotransposons. So hopefully this will be the start of something good where we can get them on multiple times. So this is going to be, I'm excited, man. And SFB mob, I've seen your stuff, brother. We got to get you on. Doki says, distractions are good energy. We can get a part 2 and 3 out of standing. Yeah, I even told my wife, I'm like, honey, just going to go live, smash Dan's arguments for 30 minutes. We're an hour into it. I haven't even gotten to the Abiogenesis challenge yet. Okay, so let's get rid of this. Boom, boom, boom. Actually, I'm going to point this out. Dr. Stadler is probably going to be with us in a week. I'm just going through both his books. So I want to finish reading those before I have them on, but I've read through a good chunk of both of them. Awesome. This Origin of Life reality check is awesome. Dessel says, let me put it up on screen so I can read it better. Can you send me an email with the links or titles to the main papers you've been relying on in your most recent discussions? This Sanford paper and the others you allude to. Yep. And my good man, I'll send you some others too. I also recommend, I still challenge Dan to go. Now, I spent about 30 minutes on the HAT map data, how the numbers line up with young Earth creation expectations. The HAT map data, I mean, when it comes to the gene deletions, the large linkage blocks that exist, everything in it suggests a young genome and is contradictory to evolutionary theory. So, okay, so let's get into this next phase. And Dan's not really going to have anything else left after that unless he wants to now not assume created heterozygosity. If that's the case, here's the challenge. So as we know, naturalistic evolution says all things came from a single cell, and that single cell came from something like a primordial soup. Okay, and I'm asking that everybody, if you haven't yet seen it, go watch our discussion with Dr. Ryan Hayes. So now the question is this origin of life scenario from non-living chemicals scientifically plausible. Now, here we go. RNA or DNA world, they're looking to the RNA world, seems to be the most researched position on abiogenesis. That requires the abiotic synthesis of building blocks of both DNA and RNA in close proximity and preferably under the same geochemical scenario. It is in this area that the researchers seek to make a contribution, demonstrating that certain building blocks of both RNA and DNA can be synthesized with prebiotically plausible reactions and substrates. Problem is, RNA world experiments involved, and we discussed this in our interview there. And once again, I've expressed these problems in the last few videos, but there's been no one answering the question. So these experiments involve a long series of highly orchestrated steps, which include purifying desired products, removing unwanted byproducts, changing physical and chemical conditions, adding unrealistically high concentrations of assisting substances, and other interventions to ensure that the target molecules are achieved. It's very highly manipulated and controlled chemistry, has no relevance to the early Earth. It's so funny. They got all the most brilliant minds, doing everything they can to produce life, and they still haven't. That alone I find to be fascinating. But here's the thing. Let's give you all the nucleotides you want. Have them formed, activated, and ready to line up into nice polynucleotide chains. Let's even give them the right proportions for optimum effect. I'll give you the most hospitable environment for your structures to form. Throw whatever energy source in you want, just the right amount to facilitate the chemical reactions, not too much to destroy the formations. And yet we'll still see that life cannot be produced from non-life, because we would even have to step in to prevent the inevitable interfering cross reactions. But with I wanted to go over the questions that I had on, let's see, I want to make it as fair as possible and word it as, okay, so, well, here's something that came to mind is I still find that people are actually looking to the Milli-Urey experiment. And I don't know if they're just parroting things, because in that experiment, they didn't find any large biomolecules. They did not find any nucleotides. Real chemistry goes in the opposite direction than is required by the origin of life, which says life came from non-living chemicals. Water tends to drive the reaction in the wrong direction. A primordial soup would have lots of water in it. Water destroys the bonds faster than they can form. And we touched on in the Dr. Hayes discussion interview the rescue device for that and demolished that too. So just be sure of that when you take the challenge. Now, as we talked about earlier, the most common scenario for the origin of life is called the RNA world. They imagine an ocean full of RNA molecules that somehow learn to reproduce themselves and slowly evolve, change, come together into the first reproducing organism. Is this the final straw in the origin of life research? It seems to be, because we know RNA is more unstable than DNA. We have our cells, trillions and trillions of them, one cell being more complicated than the most advanced automobile on this planet. But we have about 1 million DNA breaks every single day. But yet most of these are fixed by the amazing repair systems in the cell. Here's my question. If RNA is less stable than DNA, and DNA requires numerous amazing DNA repair systems in order to actually survive over time, how on earth can an RNA world be plausible? The building blocks of RNA are threefold, okay? We're looking at a sugar, you got a base, a phosphate. I've issued this challenge so many times, I could probably just say all this with half asleep, because we're looking for answers. You got your sugar, base, phosphate. Naturally, these things don't bind to form nucleotide bases, okay? That's actually needed for RNA. So right from the start, what we're looking at here is we've got a major issue even trying to get the building blocks for RNA. The building blocks themselves are incredibly unstable. And they want to scoff at front-loaded genetic diversity, which, as a matter of fact, leads to testable predictions, leads to SFB mobs at 740 trillion on average. Amazing, eh? All happened by chance for no reason at all. Here's the thing, though. I like this. Okay, this is fascinating. We got the more we study these enzymes, the more fascinating it is. These enzymes are needed as a catalyst in the cell. Now, yes, I know RNA can do this in a very limited extent, okay? But the reality is that in living cells, protein-based enzymes do most of the work. This is a fact. How did life change to the critics? How did life change from, and I don't want the storyboard. We're constantly getting the storyboard. We're sick of it. If I wanted a storyboard, I get it. I get enough of those at night when I got an hour-long bedtime with the kids. We read a couple Berenstain Bear books. That's it for story time. We want empirical science. So how did life change from RNA enzymes, from which there are only limited support, to these amazing protein enzymes? When did this occur? Deal with the chicken and egg problems here, okay? Because the information in the DNA requires enzymes to read it. But then those instructions to build the enzymes are on the DNA, which, guess what, cannot be read without the enzyme. So which came first, the enzymes or the DNA? And please don't resort to the enzyme first or metabolism first fairy tale, because that's been destroyed. And I would love that to be the rescue device. We're going to have Dr. Hayes on to destroy that one. But here's what I really find interesting too, is they're constantly arguing for these biochemicals. Well, here's this biochemical formed, whatever, let's extrapolate that to say origin of life. Guess what? Life itself is not just based on biochemicals. You can have all the biochemicals you want. Kind of like I said earlier, have this, have that. Let's get rid of this problem somehow, and you're still not going to get life. But here's the thing. You can have all the biochemicals you want, and it's not going to give you life. Okay? You can have all the amino acids you want, all the proteins. You can have RNA. You can have DNA. Stupid Whore Energy, thanks for the super chat. You better be there for tomorrow's debate. Doesn't it give you pause that RNA is the most central processing unit of the most important machine in life, the ribozyme? Yeah, it's fascinating stuff. Fascinating stuff. There's so much interconnectedness going on. And SWE, I'm not sure if you're trying to defend abiogenesis there, but have RNA. Add a little DNA then. But number one, they will never assemble themselves. And even if they did, we still have not introduced what? What do we got to introduce into the molecules? Anyone in the chat? Information problem. Let's think about information. I'm just going to use the same analogy. I like to think of it like a book. The ink molecules is not information, okay? It is ink molecules written on paper. That's it. You could pour ink. You could spill ink on a page. Oops. And you're not going to get information out of it. The information comes from what? A mind. And that mind organizes those molecules into words, sentences, paragraphs, chapters, books, encyclopedias, libraries. Give me a break here. So, yeah, that's the last time I'm going to issue that challenge. That's a few times now that I've done that. Check out the interview too. And data without purpose is noise. Amen, brother. I can't wait to have you on, man. We got to team up for sure. Yeah, these guys are. And guess what? Any of these critics are always welcome in our spiritual family. God would wish that everybody would come to repentance. So a lot of times it's not about the evidence, though. There's something a little bit deeper. Okay, let's get to this linkage disequilibrium. Okay, that was an hour of fun. Dan's final argument has been dealt with. And, I can even challenge. They said, why did you put Gutsy Gibbons' name in the last stream too? Because she's parroting the same arguments. She's saying, creation's been destroyed, demolished. Let's see you actually deal with some of these genetic related arguments that you sometimes speak very authoritatively in regards to. They're just all, relying. They're all putting it on poor Dan. Give Dan a break. Come on, let's see some answers. So, Doki Doki says, Team Joel and SFT merger. Yeah, we got to have Joel on. Dessel sent you an email for those papers. Let's see. A good man going over to my email. My Gmail one. Yep, there it is. I'll send them to you. And what I appreciate about Dessel is he watches these debates. He watches them, judges them objectively. You can go check my debate playlist. I've had over 70, and a lot of them with the same. I've debated Erica 3 times. I've debated Dr. Frello. I've had a lot of good memorable Conspiracy Cats a couple times. I've had a lot of really good debates. But now I am challenging a lot of these more popular evolutionist atheists. Professor Dave would be my number one pick. I personally don't think he'd stand a chance. I don't think he's ever heard of our predictions in regards to molecular clocks. Vice Rhino, we made a few-hour video demolishing him. I've challenged him to a debate, so definitely don't want to debate the same people over and over again. So let's see here. So Dessel, if you can get actually Dessel asked Professor Dave for me. Dessel has asked. I've had other people ask, and he has said no. Yeah, you're right, Nicholas. He's nothing. He's just popular. I think he's got a couple 100,000 subscribers, so I'd like to debate him. Destiny. What's funny is I find these popular guys, I'll give credit where credit is due. I feel like the less popular ones, and I'll even throw Emo in there. Credit where credit is due. Emo, Snake was right, Speed of Sound, Erica, Dan, of course, probably even David. These guys seem to have better arguments than your more popular YouTubers. And I think that's why they kind of refuse to actually debate, because they've got a lot of subscribers. If they go into a debate with an informed creationist and they lose, they get manhandled, destroyed. It's not going to look good. They got a big audience that they want to look good in front of. That's why typically you'll have your Pelagia or your Vice Rhino, they're writing a script. They'll go read the script. Oftentimes I'll have a script for these, but I'm constantly going on rabbit trails and kind of just going from memory and stuff. These guys go in their videos, they write a nice, neat, and organized script. But that's why they won't debate, because if you get them in a debate, ask them a question, press them, push them hard, well, they're going to look foolish in front of their large audience. So I think that's what the issue. Yeah, Dessel, my list at the top of my head would be like Vice Rhino, Professor Dave, Aaron Ra. He recently said no, and I even suggested Erica could moderate. He still said no, but he didn't want an equally timed debate. And then, did I say Pelagia? Destiny, he debated Kent. He's got a big audience. I'd debate him. Anyways, let's go back on topic here. Dan's going to accuse me of going off topic, and he's kind of right. I'm going rabbit. I like to interact with the audience, so people ask questions, and you guys are great support. Super chats, super stickers. So love you guys. You guys are awesome. So let's go to Linkage Disequilibrium. One Punch Man wanted to know a definition of it. So definition, pull it up on screen. Linkage disequilibrium refers to the non-random association of alleles at 2 or more loci in a general population. When alleles are in linkage disequilibrium, haplotypes do not occur at the expected frequencies. This is another question that oftentimes comes up and people mix. Linkage generally refers to the physical state of being linked due to the chromosomal organization of the genome. Linkage disequilibrium refers to the presence of a statistical association between allelic variants within a population due to the history of recombination, mutation, and selection in a genomic region. Now, right off the bat, I'm going to ask the question again really quick. The large linkage blocks that exist in the human genome, okay? And this is the entirety of humanity. We're all 99.9% similar. The Y chromosomes, little variation. Mitochondrial DNA, little variation. I've been asking over and over again. I've asked to Erica, I've said, hey, listen, where's an example of a highly divergent or highly mutated Y chromosome if the Y chromosome is doing so many weird things? It doesn't exist. The low variation, the fact that all Y chromosomes on this planet are incredibly similar speaks to the youth of the genome, especially if the Y chromosome is mutating fast, doing crazy things. Well, then obviously if we're all still so similar and there's no highly divergent Y chromosomes out there in some subpopulations, well, you know, show me that data. But yeah, so the fact that there's so many large linkage blocks, and given what we know about recombination and gene conversion, in a young timescale, this makes sense. They exist, even considering recombinational hotspots and cold spots. So many large linkage blocks exist because we have a young genome. But if we've been evolving for millions of years and we've had, but by the time humans came around, okay, 100,000, 200,000 years ago, the genome would have already been highly shuffled due to gene conversion recombination. Now it's been another couple 100,000 years, and yet there's still so many large linkage blocks. Why? How's this possible? Anybody in the chat have an answer? You know, how is this possible? The genome should be scrambled to nothingness. Now, the only one who has given an answer was Dan with recombinational hotspots. But it's circular. It's kind of like the orphan genes. You know, they can admit, it's kind of like genetic entropy too. There's clearly shelf lives on genomes, but they can't admit that the genome's obviously young then. You know, they got to come up with this rescue device, this rescue device. Even considering recombinational hotspots, it's not going to account why most of the genome has not been scrambled to nothingness. So there's your definition there. Yeah, here's the thing, SFB mob. Based on the amazing DNA repair mechanisms, all the evidence for pre-programmed genetic change in our genome, here's the thing. These mechanisms require forward thinking. They're forward-thinking mechanisms. This speaks of a forward thinker, you know, and these evolutionists want to put mind on evolutionary processes, so... Okay, let's get into this part. What I'm about to go do now is what the video was supposed to be on. But then Dan came out with his video, and it was too much fun to not want to break it down. Okay, I'm going to get rid of this. And linkage disequilibrium. So let's see if we ever get an answer to the linkage block problem. And what I find funny is I've asked Guts and Gibbon in the comment section a variety of these questions. So, well, I'm editing on a video, you know. It's like, can you just answer the question here? These are questions that have been asked for months. You know, these people got to make videos, go gather all their best minds to come up with the best storyboard possible. Okay, so there's something called linkage disequilibrium in the genome. What is LD? Let me break it down for everybody. Okay. Genes are located on chromosomes in cells. We know this. Now, these genes may either be distant or close to each other. Now, there's a good analogy to make this all simple. I'm going to give credit where credit is due. I got this analogy from Dr. Dan. I think it was a great way to understand it. So before we get there, though, all of these genes that are located on one chromosome are then said to be linked. When cells divide through meiosis or genetic recombination, it often occurs in the nuclear DNA. This involves two chromosomes aligning and swapping segments of DNA, resulting in genes getting shuffled around. This is what I was talking about earlier, that if we've been evolving for millions and millions of years, recombination gene conversion is always happening. And therefore, after so many generations, the genome should be shuffled, should be scrambled. Yeah, anybody in the chat, if you've got an answer to that. Been waiting for months, years. I don't think we're going to get one. Sometimes you just got to tap out and know when to praise your creator. So here we go. The closer that two genes are to one another, the higher the chances are that they will be inherited together because they're close. It is unlikely that they will be separated during crossover. When this holds true, the genes are said to be in linkage disequilibrium, a state in which they are not thoroughly mixed, but tend to be inherited together in populations. Now, over time, crossing over mixes up genomes, okay, so that they become more what? Homogeneous. Now, SNPs, okay, single nucleotide polymorphisms, which actually accounts for the bulk of diversity in humans. They're point mutations that are relatively common to a genome, being present at a frequency of roughly 1% of the population. Now, many SNPs are associated with each other on chromosomes and have been inherited together in populations. These blocks of SNPs are called haplotypes, and LD refers to the existence of such non-homogeneous relationships. Crossing over breaks down ancestral haplotypes over time. In other words, it separates the single nucleotide polymorphisms and therefore decreases the extent of this linkage disequilibrium. Now let's get on to this analogy. So if Dan's watching, if he's listening, lurking around, feeding the baby, watches tomorrow, thanks for the analogy. So consider this. Consider shuffling a deck of cards, okay? Imagine that the 5 of hearts is in very close proximity with the 9 of spades. The closer these cards are together, the less likely it is that they will be separated by the shuffling of the deck. This is analogous or comparable to crossing over. Now, until all such relationships are broken between cards, they would not be thoroughly mixed, of course. And this would be a state comparable to linkage disequilibrium. In the same way, the distance that LD extends across the genome is broken down over time, and there is a decline in LD with increasing distance. Okay, now that we got that out of the way, first off, and we're going to be discussing this with Dr. Carter Monday too, I want to point out the fact that many people, not even just creationists, okay, acknowledge the fact that just because African diversity is mostly larger, they have more diversity, and therefore they assume this is a function or indication of the greater age of African populations, okay? Dan's made a full video on this. I debated David on this. Great debate. Go watch it. Genetic diversity is, however, also a function of what? Population size. Okay, so it should be noted, and this is why I find it funny, the evolutionists, they just want to convince their audience. They never want to tell both sides, give the alternatives. I'll do that right now. It should be noted that diversity due to a large population size can then be incorrectly interpreted as being due to a greater population age. In a nutshell, for people to understand, let's make this easy. All that would have needed to happen when it comes to the African diversity versus the non-Africans is that more people simply ventured towards Africa after Babel. Perhaps they had come from the east, journeying west. They sought to continue. Many would have then ended up populating Africa. If this model is indeed correct, and we know there's some historical evidence for this anyways, more humans then settled in Africa. This larger population size could account for the greater genetic diversity found there. Now, because I've got Matt and I did a really lengthy video, went into incredible detail. We touched on this. It was a response to Dan. That'll never be responded to, of course, which is fine. But the silence is deadly. And we reviewed, critiqued one of Dan's videos where he critiqued one of my books, and we touched on this. So, but that's why, I'm just going to make this easy. And instead of, spending an hour on this, let's explain it according to the biblical model. I've explained this many times. I've also asked my own linkage questions that I just reiterated at the beginning. We've received no answer to. So since I've answered this ad nauseum, I'm just going to tear this apart directly from my irrefutable new book, Refuting the Critics. They love that. Okay. So I say, Doki Doki, thanks for the super sticker with the upside down smiley face. Love it. Okay. So Refuting the Critics. And then we're going to end it here. I got to get some sleep, get ready for the Ken Hovind debate tomorrow. It's going to be fun. Okay, so another very persuasive line of evidence supporting independent origins and the biblical creation model has to do with human linkage blocks. Human chromosomes are made up of relatively large linkage blocks, just like I explained earlier. Now I'm just reading a source, that source being my book. So Pelagia besides MDD, Pelagia to Decel, well, I think it would have. I At this point, I'd want to make it MDD because James has done so much to help my channel. He's had me on so many times, and I promised him I'd try and get some bigger names for the channel. Recently, I got Dr. Garrett on, which was good. So at first, I'd want to try and push for MDD. I don't see why anybody would not want to just. I don't see why Pologia or Professor Dave or any of these guys wouldn't want to go on MDD. It's neutral. James is a great moderator. So let's start with that first. Anyway, let's get back to this. So when these original text strings are analyzed, we find evidence for a youthful genome, just as I said earlier. This is because the genome has only been moderately scrambled. Sound familiar? Just like I explained earlier in this video. Okay, in the article, in light of genetics, Adam and Eve and the creation/fall. Yeah, Dessel, I see. I'm going to send those to you, my good man. I'd love for you to read it and give me your thoughts too. And make sure, Dessel, you highlight the spot where it discusses linkage groups. Look at the simulations. Look at the parameter settings. Look at the graphs, the data, the conclusions. And just see that Dan clearly didn't read it or skipped over linkage blocks. Okay, so Dr. Sanford and Dr. Carter, reading directly from my book, points out the fact that crossovers and gene conversions should have scrambled all linkage blocks fairly quickly if deep time evolution is true. Okay, so now I'm going to quote them. We can actually see bits and pieces of the intact chromosomes of the first human beings. By pooling the data from many people, we should eventually be able to reconstruct chromosomes of the first human population prior to human recombination or mutation. This would be especially significant because the new data is showing that the rate of recombination is much higher than previously thought due to what are called genetic conversions. Isn't that funny that Dan ignored that earlier in his argument? Maybe because it doesn't make his argument sound as good as he thought it sounded. Funny. Well, I predict that there won't be a response to any of this, by the way. And if there is, he'll just dodge the hat map. He'll dodge 99% of it. Okay. See, here's the thing, and Dan, I guess he's a nice guy, and I always say no hard feelings. But problem with Dan, I don't mean this to be mean. If he's trying to be like an apologist to fight young Earth creation, he's not very well-rounded. He won't. It's okay that he's not venturing outside his field. That's his expertise. But like anything that's just even slightly outside of it, just ignore. Doesn't want to deal with it. So I don't know. He emphasizes the fact he wouldn't want to ever debate creation versus evolution. And I understand, it's good to one topic at a time, but I can see why he wouldn't. That kind of, because when I debated Dr. Frello, and Dr. Frello says he's been fighting young Earth creation for years. He's got his own blog, fights AIG. So we debated creation versus evolution, and everything outside of genetics that I brought up in his rebuttal, he just tapped out and said, well, I don't know those topics. See, the thing is, when you say you've been fighting young Earth creation for years and you're fighting AIG, you should at least learn the basics on how to debunk the flood and other topics besides, I guess, what your expertise is in. And I think that I've reached out to Dr. Frello 100 times in the last few months to debate again. He debated Jensen. I want to debate him. He's at least respectful and uses the same arguments as Dan. And I'd like to debate Frello, but he hasn't gotten back to me. So, okay, so let's get back to this. Genetic conversions. These conversions happen at a much higher frequency than chromosomal recombination by crossing over. Isn't that funny? Therefore, crossovers and gene conversions should scramble all linkage blocks quite quickly in an evolutionary time frame. This is a big problem for evolutionary theory. First, because evolutionists do not believe there was ever a first population of humans. And second, because they assume that any original population would have included at least a few thousand individuals whose chromosomes would have already been ancient and extremely well shuffled. Remember, I explained this earlier in my own words. They're reiterating it here. They're confirming it here. And these are PhD geneticists, marine biologists. So these guys know what they're talking about. They continue. From an evolutionary perspective, there should be complete shuffling of the genome in deep time, with hardly any trace of original chromosomes surviving. But the preliminary data strongly suggests that we can discern much of the original chromosomal text strings. The preliminary data looks like the original chromosomes were few in number, representing a very small initial population, perhaps even as few as 2 people, Adam and Eve, or just 6 people, Noah's 3 sons and 3 daughters-in-law. This is an area of active research, but the preliminary data seems promising. I said this to Downard in our last debate on Adam and Eve, which was a hilarious debate. He brought no evidence for human evolution, which is what he was supposed to defend. There's a double standard when it comes to these debates. If I debated Adam and Eve versus human evolution and I came and only attacked human evolution and didn't defend my position, those comments from those atheists in MDD would have said, I ignored the topic, I got smashed. But RJ Downard ignores the topic, doesn't provide any evidence for his position, but, you know, nobody bats an eye. Okay, so anyways, back to this. So proponents of universal common ancestry, this is back to what I say in my book, have a difficult time addressing this profoundly serious problem. Many critics have claimed that if the biblical model of independent origins were indeed true, we should be able to determine what Adam and Eve's original genome looked like. As you can see from the citation above, the preliminary data in determining their original chromosomal text strings is very promising. This is yet another example of the critics of biblical creation not staying up to date on the relevant literature. SFB Mob, have you ever studied Fibonacci's work? A little bit, not really, but I find it amazing. That's why I'd love to have you on, discuss these things, man. You're really knowledgeable. Faithful, Honest, and True says, I like Frello. Yeah, I had a good debate with him. We've emailed me, but he hasn't he hasn't emailed me back, messaged me back. I'm not sure if he wants to debate again. There's another chat. Nicholas. I don't think such a debate is Pelagia's thing. Yeah, I don't think he's going to debate either. I don't think he'll risk it. Because he doesn't want to risk losing credibility since he likes to focus on the videos, creation versus evolution. So in a debate, people might realize that he doesn't know as much as he makes himself out to appear like he knows a lot. But I've got Ken Hovind, who is willing to debate anybody. I'm constantly setting him up debates. He would debate Pelagia. He would debate Vice Rhino. He would debate any of these guys too. So put the challenge out there as well. SFB Mob says his work proves what you're talking about. That's awesome. But we definitely got to have you on to discuss this. Okay, so let's see. Continue. This is yet another example of the critics of biblical. And now remember, this is one of Dan's main arguments. And, you know, since it's been addressed so thoroughly, you'd think that he'd want to, it's his loss anyways. That's fine. Okay. So they criticize a model that they do not understand. They bring up arguments that have been addressed. And I go on for a little while here, but then I get back to the rescue device. So the rescue device, when it comes to the linkage block data that suggests humans are young, is what? I explained it earlier, recombinational hotspots. This is yet another rescue device. This argument has been dealt with sufficiently in the same article cited above. Dr. Sanford and Dr. Carter give us a detailed breakdown as to why this argument fails. Let's go over it. Evolutionists try to explain the ubiquitous preservation of the original linkage blocks in terms of recombinational hotspots. They would say that crossovers and conversions do not happen randomly along the chromosomes, but must more frequently occur in the areas between the observed linkage blocks, which they would say are the hotspots. We believe they are using circular reasoning. They're assuming that since the human genome is extremely ancient, right, that's their starting point. That's their presupposition. You can't question the bigger picture. Question the details, not the bigger picture, right? Now, they're assuming the genome is extremely ancient and there never was an original Adam and Eve. Therefore, observed linkage blocks prove that all such intact linkage blocks must be cold spots. Isn't that funny? Zones where recombination never happens. Because there's areas in the genome where it looks like recombination, they've never been shuffled. It's almost like the original Adam and Eve chromosomes. Now, they continue. We do not think that this is an adequate explanation for the preservation of ancestral linkage blocks through deep time. Okay, here we go. Let's address more of Dan's arguments. Africans tend to have chromosomes that are subdivided into smaller blocks than non-Africans. Evolutionists use this as evidence to argue that African populations are older. Remember we talked about that earlier? older than other people groups. And so Africans are the earliest humans and predate other people groups. Pretty simple, right? Well, guess what? This interpretation is problematic on several levels. We covered a few of them earlier. Linkage blocks are not detectable except where there is genetic diversity, because this is needed to map the ancient recombination events. African populations are known to be more diverse, which largely explains the smaller and better mapped linkage blocks. Isn't that interesting? African diversity does not require more time for mutation accumulation. It just requires that a larger number of tribes arrived in Africa. Remember I explained that earlier? After the Ode of Babel dispersion. More importantly, okay, and none of the critics are going to argue this. This is all real data. It's not a rescue device. So I'll continue. More importantly, certain people groups probably, this could lead to a testable prediction. It has led to testable predictions. Probably have different rates of gene conversion, different rates of chromosomal recombination, different historic population sizes, different average ages at marriage, and different rates of childbirth and mortality. All of these affect the what? The genetic makeup of people groups today. And these features are all variable in different people groups. Example, it is known that Africans have more recombination events per generation. There you go. Isn't that significant? Address that one. Even though rates of change are not uniform, all people groups must be the same age, tracing back to the same source population. And isn't that funny that your uniparentally inherited DNA, non-recombining DNA, takes us back to just two common ancestors in the not so distant past, based on a number of lines of data, lines of evidence. So, yeah, that covers that. You know, we're at this point we're going to be beating a dead horse. But I hope everybody liked the Vice Rhino video, because regardless of his Pelagia, Professor Dave, these guys don't want to debate. We're going to be hitting them hard in our new evolution. Another evolutionist bites the dust. So let's see here. The chirality problem actually is another thing I was going to get to into the challenge. But I thought it was enough problems that I gave them, but that would be another one. Explain the chirality problem. Where's the solution for that? Let's see. Doki Doki says maybe Standing is scared of Pelagia because he's a former, these former young Earth creationists are hilarious. Dapper Dino, you know, he's got he's another guy that's not very versatile. So he has this show that he gets once in a while, former young Earth creationists. I'll give an analogy. So when I coached wrestling, when I did wrestling, that would be like that person who came to wrestling practice for one day. I taught them a couple moves. We sparred. We did some workouts, called it a day. And that guy hated it. So he never came back. But years down the road, he was telling people that he was a former wrestler because he went to one practice. And you can use this for boxing, whatever analogy you want. That's the kind of young Earth creationists, former young Earth creationists you'll find on these channels, the Dapper Dinos show. You know, they've watched one Ken Hovind video or something way back in the day, and you know they were a former young Earth creationist. Because every time I interact with these guys, when you listen to them talk, these guys don't know nothing. I debated a so-called former young Earth creationist a year and a half ago, and faithful, honest, and true complains about Kent. Yeah, he's. I think Kent's going to get a restraining order on him soon. All the videos he puts out on Kent. But so I debated Wayne Fillmore and former young Earth creationists. He knew nothing about even genetic entropy. These guys don't know anything about the most technical data. Show me a former young Earth creationist that's on the level of, my audience who really knows their stuff. I'll say I love watching SpongeBob Imagination. Hey, brother, good to see you. I love watching you in the comment sections. You destroy these guys. They always give up. SpongeBob Imagination always wins. He says, it's an old propaganda technique. I used to be a believer just like you, but then I learned the science. Yeah, exactly. But then they can't explain the science. They're not up to date. They don't know the testable predictions, the best arguments. It's like deer in a headlight when you bring up these arguments. It's like, I thought you were a former young Earth creationist. Show me a former young Earth creationist that's on the level of people from our audience, people involved directly in this channel, Dr. Jensen, Tompkins, Sanford, Rob Carter, you name it, Purdom. Show me a former young earth creationist that's on that level of knowledge. You won't find it, because once you see the data, there's no going back to Pond Scum to People Evolution. You know, Dan wants to nitpick at these little things, yet he's the one that believes all life we see today, humans, banana plants, dogs, fish, reptiles, all go back to a single-celled-like ancestor. And that single-celled-like ancestor evolved somehow from non-living chemicals. You know, this is SpongeBob imagination is what it is. Evolutionists hope, dream, and imagine. But yeah, show me a former young earth So One Way says he's a former young earth creationist. I don't know if he's joking or not, but if that's true, we'll have to come on here and have a molecular clock talk or genetic entropy. So here's the thing. Yeah, the scientific data, the empirical evidence, that which is high confidence science, testable, repeatable, observable, things you can retest. You know, the empirical method, it confirms a young earth creation model, and it's consistent with theology. So, well, it looks like we're going back on, yeah, Faithful, Honest, and True says, name 5 young earth creation predictions. It's so true. Faithful, Honest, and True. I'll ask, just name one. And they still can't. One of my first discussions with Dan, I asked him to name one prediction of Jensen, who he's been critiquing for years, and he couldn't do it. Yeah, so let's see. SFB Mob in real time at Standing for Truth. You got that right, brother. Caustic Soda, former old earth creationist. Yeah, man, the data, you know, once people see it, study it, they can't go back. SFB Mob, I think people want to pretend evolution is true so they can hope God doesn't exist because of some sin they want. Amen. Amen, brother. I've been saying that for a while. A lot of the times, it doesn't have to do with the evidence itself. That's why what we do when we're debating these militant evolutionists, chances are they're not going to get saved. They're not going to convert. You know, they're too invested. Someone like Gutsick Gibbon, she's going to be a primatologist. This is her livelihood. This is her job. You think she's just suddenly going to tap out and say, everything I've studied, all the money I've thrown into this program, it's all a lie. Dr. Dan, 15 years of school, evolutionary biologist. You know, he's not just going to tap out. He's going to either ignore the evidence, dodge the evidence, focus on the 0.1% of the data that maybe he feels we can't address. I don't know. But then yet won't address any of the major issues with their problems. So, you know, so these people, they're too invested. Not to say that they can't convert, but, you know, there's a lot of humility that would be required there. Pride is often an issue. Some people have sins they don't want to give up. Not that you have to give up sins to be saved, but some people have that sin that prevents them from wanting to believe in God, especially the God of the Bible. So spot on. That was 100% accurate. Praise I am that I am. Yo, that extra large coffee was good today, Praise. It was awesome. One Way says, I'll come in and talk to you right now on the exegesis, eisegesis, hermeneutics, soteriology. Yeah, they love those big theological words. He says, I appeal to exegesis, not science. Yeah, because they can't address the science. So, like with IP and Sentinel apologetics and all these Bible compromisers, they the amount of times I've asked them to discuss the science, put it out there, they won't do it. They don't know. Anyways, getting late. We've gone for a couple hours. Good to see everybody. It's been fun. What I thought was going to be 30 minutes went for an hour and 45 minutes. But you know what? We'll call this the final blow, the fatal blow to Pond Scum to People Evolution and these critics, because it was funny to hear Dr. Dan say, like, you know, this was the big bulk of my argument. So I thought, you know what, even though it's been addressed, let's do almost an entire stream to it. One Way says, good night. Love you, SFT. Love you too, brother. I'm just playing around. Let's see. I'm a former postgrad, super redeemed energy says. Embarrassing, I know. You guys are awesome. Everybody in the chat, thanks for being here. Dessel, be my agent. Try and get some more opponents for Kent. I got Derek to agree tomorrow. I think I'm close to doing another one, but yeah, see if you can get any of the big shots for it, and we'll work together on this. So anyways, Nicholas, yeah, look, I know, not possible. Not possible. It's too much fun refuting these guys. Exactly. But one way, from my understanding, rejects evolution. He's just old Earth, which is not as bad, I'll say. As long as, I think, I don't know what I think about these theistic evolutionists that'll say humans and apes are related, or humans and apes descend from a common ancestor. It's like, just way to just reject, an Adam and Eve. If there's no first Adam, what's the need for the second Adam? So, all right, guys, it's been fun. SFB Mob says, that's your third yawn at Standing for Truth. I know. 4:30. All right, it's been fun. We are calling it a day. I'm going to go to the ending video, and thanks for being here, guys. Thanks for the super chat, super stickers. Hope you guys had fun. Hope you guys learned something. Email me if you got a question. And until next time, see you guys tomorrow for the Dr. Dino debate.
And for those who enjoy this channel and would love to support us financially, please feel free to hit that donate link. We'd greatly appreciate it. God bless.